deep offline. Let's talk about this tonight. And my congratulations, you're survivors. Last day and last session of this beautiful conference. So here is you, here is me with my session, and after party is very, very soon. Hope to see all you there. But before, let's discuss what is offline-ready web application. How to send your web application to offline in a good sense, of course, and how to do it today. My name is Maxim Salnikov, and I just suddenly realized that this intro slides looks like search engine optimized page for PWA keyword, right? But this is true. This is my activities. I am a big fan of progressive web apps. I'm an enthusiast. I organize lots of activities around this. What could be useful for you from this slide is my Twitter handle. I tweet mainly about web platform, about new cool possibilities, and of course about progressive web apps. Let's start with this 3 points I found when I created this material. So this is research paper from folks from one company. I will not tell you the name now. And it's about web. First, you agree that web is new software platform? Absolutely. Browser's new operating system. We have Chrome OS, which is exactly what's written here. And of course, no doubt that JavaScript is dominating this world. So all these 3 points are very relevant, fresh, and up to date, right? But who can guess the date of this research paper? Like how many years ago? 10. You are close. 11. So just imagine, 11 years ago, these ideas were like well-shaped, well-formed, and the folks are from a company called Sun. I didn't name this because you might understood then like approximate epoch. And this is true. Web as a platform is great. Browsers, they are everywhere. Browsers or web views, and they are fresh, and they have cool APIs to access hardware of our devices. JavaScript. We can have different opinions on this language, right? But no doubt it's very versatile. You can apply different paradigms to code in JavaScript. If you don't like code in JavaScript, you can code in some other language, and powerful tooling will transpile everything to JavaScript, plus the support of IntelliSense and all other features is the best in class for pretty much every IDE we use. And a very smart and very conservative way to evolve to make sure that we do not break any previous versions, right? Engines themselves, we do not have big control on what folks, for example, in Google or in Mozilla do for their JS engines, but we can make sure that everything they do, most things that they do, focused on performance. This is why I put this point very, very big, and this is very important. Plus, there are lots of different JavaScript engines that we can embed to this or that device. It's super easy for me to introduce everything about UI, right? Because yesterday there was CSS conference, and of course, like no doubt, we have today really cool opportunities to build nice UIs with focus on being accessible for many people as possible. And thanks to open source, thanks to all these great folks who contribute to open source, we have a variety of different libraries, so we can just pick the best we want. And community, all of us, right? According to the latest survey by Stack Overflow, almost 70% of folks say that they know JavaScript, right? And by the way, last year this percent was bit higher, so maybe some folks realized that maybe I was wrong. I don't know JavaScript enough to say that I know this, right? Because JavaScript is really endless in its learning curve. Are there some problems? Well, yes. World Wide Web was not invented for how we use it today, and JavaScript was not invented for building full-scale web applications. Web itself is very tightly connected to the connection status, right? So often we say web and we think internet. We say web application, we think some URL we need connection to access to. And about JavaScript, I think I started to do something in late 90s of the last century, and one of the first real-life applications of JavaScript was something like this for New Year time and for Christmas time on the website. Who did this? Raise your hand. Yes. Who still does this? Yes, of course, we don't have to prove anymore that JavaScript is cool, JavaScript can do such things. It can, but let's use this for good. Web, offline web. Of course, there were many tries to make them friends, both from caching and from installation perspective. HTTP cache, yeah, it's more like a joke here because we cannot rely on anything cached by the browser. We cannot say, wow, browser cached something, hopefully now we can access this offline. No, it's not for offline experience, it's more for optimizing your network traffic. First web standards try was called app cache. And it was a disaster in terms of both user experience and developer experience. Now it's deprecated, so don't use this. But it failed partially because it used declarative approach. So we tried sort of say, okay, this file, please cache it like this. This file, please cache it like this. Like not writing the code, but providing this declaration. And it turned out that it's not enough to provide really what we want. About installation, again, sort of joke. You still can go to the browser and save page, and if you choose save complete, then it will save you something on the disk, but yes, it's not about offline experience, right? Chrome apps, nice approach, but it's far from being web standard, right? And same for Chrome extension, so it's vendor specific, vendor locked. This is not what we want. And variety of wrappers. Of course, they can do their job, but as a result, we are going away from web into the side of native application. So what if we combine our dream? What if we are able to cache exactly as we want? What if we are able to install the application? And plus, very strong requirement to keep this all based on open web standards. Can you call me the name of the idea which is embracing all these things? You are right. This is progressive web app. But this is not session about progressive web app. Anyway, let's refresh. What's this all about? Refresh in a very short and brief way. It's all about using modern web APIs exposed by evergreen browsers, right, to run our applications everywhere. Next slide is about this. Why do we need this? Of course, to delight our users, our customers, our clients, to give them experience they could get only in native apps before. And about work everywhere. Yes, today I can confirm this. Your JavaScript applications, your web front-end client-side application, which is following this idea, will work on pretty much every platform, which is, I don't know, which is still supported, which is not maybe super exotic. Of course, there is some asterisk, right? They work everywhere as native, but not everything. Luckily, we are front-end developers. We know how to deal with this, right? We just use progressive enhancement. We do feature detection. If it doesn't work here, okay, you will still get your web app. Maybe it will be slightly different from the one that you can run in fresh browser, slightly different, not in terms of this will break or will not work correctly. No, this will maybe just lack some features. It's all about progressive enhancement, and actually word progressive in PWA definition is exactly about this fact. But again, this is not a session about progressive DevOps. This is not one more getting started with PWA or like get inspired by this. Let's focus on one particular feature of this, and there is no like strict relation between offline readiness and PWA. Let's not dive deep into the terms. We want to provide proper offline experience for our users, and we'll list this properness very soon. For now, I just want to say that today we skip installation part of this. It deserves separate session, or maybe a couple of sessions. This is just a screenshot from Twitter of my friend Maxim about where you can install and correspondingly run your client-side web application in terms of operating systems and browsers. You see that list is pretty promising, and yes, as I told, you can run this everywhere natively. Let's go back to proper offline readiness. What do we want to achieve? Actually, there is nothing to invent. We can just take any native application, native for that particular platform. For example, if I use iPhone, it could be native app for Twitter, and just check how does it work when it's offline. And many details we don't even notice, but we have to implement everything as developers, both for native and for web apps, of course. And yes, one more thing. When we install the application from App Store, or we download something for, I don't know, Windows system and run setup.exe, we never call this application offline ready application, right? It's offline by its nature. So this might happen with web, and I hope this will happen with web if we are talking about some form of applications. If we ever download something from internet during our application running, in most cases we do, right? Variety of APIs we use, our APIs, external APIs, CDNs, whatever. Everything we download, it really makes sense to carefully store it somewhere and reuse it during online or during offline. So it's all about runtime caching. What we do in offline mode, what our users do in offline mode, it's really a price of gold. Every developer of native application will tell you that user-generated content is king. We don't have to lose any single byte of what folks did during offline, including, for example, statistics of their visits, so what they do, what they click exactly in your application when they are offline, and what they try to, for example, post if this is sort of messenger when they are offline. Definitely, we don't want to show this dinosaur page with server not found. We want to preserve this, and we want to resend this. Connection is not always stable, right? So if we are talking about some continuous operations like downloading large file or uploading large file, we don't have to ask user do it again and again when, for example, connection was broken. And it would be cool to have some APIs, some tools to help. Updates, both of our application and the content inside, are also very important. Again, nothing to invent here. In the world of mobile native applications, we have this auto update of apps. I think it's now turned on by default. And the same with the data these apps can download from time to time from the internet to stay fresh, even when you don't notice this as user, right? So there are some native APIs, and why not to have the same in the web? And hardware platform features. We really want to use them a lot. It's partially related to offline experience, and definitely will close the gap between what web can do and what native code can do. we need these all points, plus we want to keep the soul of web. What do I mean by soul? That it's discoverable, it's linkable, it's not separated to web when it's online, to web when it's installed. We don't want this segregation. We want web stay web with some extra features. Okay, let's just go point by point and let's check what do we have now. We start with the application UI. Actually, I added some like extra title slides this morning because I've seen this beautiful bright screen. Wow, I'm amazed. I intended to look to this duplicating monitor, but I really want to look here. It's a very beautiful screen. My question, why do I use exactly this photo when I talk about application UI? Exactly. In most of the cases, we call this application shell. There are like different terms of what application shell is in the different areas of like programming industry. But for web client side, what we mean, it's just the UI of the application itself. It's sort of frame. It looks like Polaroid picture, right? Everything that we get to the device when we actually do the installation. At least like minimal set of what we can get. And again, if we compare this to native code, when we installed our native Twitter, we make sure we know that this will always start regardless of the connection. And we want to do the same for web. In super brief app architecture session, what do we need to get this? First, we have to understand what is exactly forming our application shell, like main JavaScript bundle, CSS bundle, index HTML, of course, maybe some sets of the pictures. Then we put into some form of cache somehow at some moment. Then when needed, we serve this from cache instead of serving from network. And of course, we don't want to always show very first version of the application to our dear clients, so we have to manage versions somehow. Who can tell me the name of API responsible for last 3 points in major? Exactly, of course, service worker. And now the fastest ever introduction to service workers is just a refresher. I bet you folks have heard about this at many of different sessions because it's like service workers are even older concept and API than PWA term. So it's really like many years with us in the browsers in production. So first, this is JavaScript file, right? It's a JavaScript code, file or files. And it's sort of set of events and our code inside of these events. And architecture-wise, it's a programmable proxy between our application, the browser, and the rest of the world, which is able to cache something. We are not talking here about HTTP cache, but a very special type of cache storage, and receive variety of events, both from operating system itself, even from web via push notifications. So to some extent, I suddenly realized that it might work as a fake internet. And one of the core ideas is at least related to caching. Your application don't have to know anything about service worker exists. It just sends requests to internet like it does always. And if service worker is there, it might help. If not, we just degrade to regular application. So this is the key. And this is how progressive enhancement work, right? Again, super briefly, I just mentioned that it's event-driven code, right? So we have event called install, we have event called activate, and we do some stuff within these events, like populating cache, like managing cache versions. I do not give this code by intention. So you will find lots of samples, lots of, I don't know, code labs, something like this. But I just want to emphasize it's handmade service worker. So this is something if we want to write it by hands. We can do this, we can do some sample. What we get as result, it will be not ready for real world. Again, we will not dive into all these points to save some time. I just want to scare you a bit. It's really easy to start with writing your own service worker, with adding some code that will take this file and put it into cache storage, and you will see it's there in the browser developer tools, and yes, you can manage this. So you can easily get excited, right? And I promise, it's super fun to code service workers. You will get lots of knowledge about different new APIs, about HTTP protocol. But I also promise you'll get some extra gray hair when someone will call you from customer side and say you, why do I see old version of my application? Or even worse, why the website is offline? So be very, very careful, starting from this point. Serving from cache. Again, we have event called fetch, which is intersecting all outgoing requests from our JavaScript code and HTML markup, if we are talking about, for example, images. We can write very explicit, very imperative code to get something from cache, and yes, so after we end up with writing some form of routing, right? Because for different pieces of our application, for different use cases, we might want to implement different logics. And again, the pitfall is here for you, set of pitfalls. It's quite challenging to write something production ready here. And after all, you will end up with writing your own router, and yeah, maybe your code will not be production ready again. Is there something that might help us to take care of these last 3 points? So we will not write at least this like basic functionality to provide proper offline experience. Anyone can tell me the name of industry standard library we use now in PWA world? Workbox. Yes. This is by fact maybe the only fully featured and production-ready library with pros and cons, right? So we don't have to twist our brains to select something from 10 of different libraries, but of course we really need good competitor to Workbox because it's not very good when some library dominates this area. So, folks, I encourage you to write something own. Start with simple service worker and extend, and the world needs something else except of Workbox. And I really want to present about other beautiful libraries. So, what are we waiting for? Let's just install this, and for my super minimal demo, we'll need only one part of Workbox called Workbox build, which is in use only in development mode. You remember that we still have to define assets we want to have as a part of application shell. So here it is. It's just in form of patterns, or you can be very explicit. Another important point, we have to provide address of our source service worker, and I emphasize it's source service worker. So this is not something we ship. We ship it later after some updates. How this service worker could look like? Again, in very minimal form, it's just downloading of Workbox library itself from CDN, and this magic method called precache and route, which is actually taking care of all these 3 points I mentioned. So managing cache, putting into cache, serving from cache, and exposing very useful methods for you. But yes, let's go back to this slide. You see that to make this work, we have to inject something into this empty array, and it's exactly what we specified in the configuration. Set of our resources we want to precache, expanded to explicit file names and their hash sums. Of course, we can do it manually, but why to do it if we have Workbox build? And this is exactly what we do in like the continue of this script. You remember this is configuration from our slide before previous slide. And one method called inject manifest to get production-ready service worker. So it will contain list of all your resources you want to precache in application shell, and yeah, all the set of methods to take care of installation, activation, version management, and even exposing events to your main application code, so you can, for example, show some message to your clients about site was updated. Like the rest, is super simple. We just have to integrate this tiny workbox build script to our general build flow, and we are done. As a result, again, after doing these simple steps, you get completely offline ready application shell. And well tested, quite stable, just pure enjoyment to use this. Let's go next. Runtime. We have to very carefully save everything that we download. Of course, if we want to reuse this later, but why not to reuse this both in online mode to save some traffic, and especially in offline mode, still to provide some useful experience. If you remember this code from our handmade service worker, yes, we end up with sort of routing if we do it manually. And of course, I'm even not talking about these strategies we have to implement, and it's all about ping pong with internet, with providing lots of fallbacks. For example, if internet is available, try to get it from cache. If nothing in cache, try to do something else. Try to show something, some message to the user. If internet is available, you still have two options to download it from there or try to cache because it will be faster. So you might want to write all this logic and provide all the configuration for different parts of your apps. How it's done in Workbox. Workbox, to some extent, returns declarativeness to caching. And it's good for developer experience. And it's good again for developer experience because this declarative experience is still customizable. So if we need, we can provide custom code. So how does it look if we extend this source service worker we generated by Workbox? We provide route, for example, in form of regexp, and we apply one of few strategies to this route. And if we need, we also can add some plugins. If we want to run our custom code against what Workbox intended to cache and intended to store from this cache. So it's as simple as to start as possible and as customizable as possible, really. Talking about strategies, lots of them are already implemented for you straight out of the box if you start with using this Workbox. Same with plugins, and you have opportunity to write your own one. So runtime caching using Workbox is is very simple to start, but again, you can do everything by hands. Next, what we do when our dear user is offline. As I mentioned, it's pure treasure what folks generate when they're offline. Same with online, but online is simpler for us to track everything, to make sure that the data will go to proper endpoints of our APIs, that it will not disappear, right? We have API called background sync, and it's hard to find more confusing name for API which is doing following. It's one-time event when our device is going from offline state to online state. Don't ask me about how does it check if this offline or online, because it's quite challenging, right? Even like in our code to really understand is internet available, because even if Wi-Fi is here, it might be not Wi-Fi but Li-Fi, right? Wi-Fi without internet. So somehow browser tries its best to understand. And thanks to the power of service worker, which is running in background, we can even do something, close the tab, and this event will still happen. If we go for manual way, in our main code, we register some sync. Let's, for example, take post tweet as an example. And then we catch event called sync in our service worker. And if it has the same name, we can do some useful things. So we check this. And yes. But what useful things can we do, and how challenging is to write everything? Because now it's just some lines of code, right? So you can just implement this tonight. In reality, again, if you want to get something production ready, something with good user experience, it will take some efforts from you. Why? Because, for example, I might tweet not only one time, but I can write lots of tweets when I'm offline. So we need to implement some form of queuing, right? And of course, in service worker, we then have to iterate through this queue and propagate messages and again provide some fallbacks. And maybe we even want to provide a fallback for the case when this API is not available. And now currently it's available only in Chromium engine. Luckily, automatically this will be available in Microsoft Edge browser quite soon. Why? Who can tell me? Exactly. So Microsoft Edge will stay Microsoft Edge. The name will not change, but it will be driven by Chromium engine inside. And of course, all these perks we have related to PWA APIs, they automatically will go to Microsoft Edge, which is good for developers. Maybe not so good for I don't know, browser diversity. So there are pros and cons, like always. How it's done in Workbox. In very smart way, we might lose some flexibility on what exactly do we do when we want to fire this event, but it covers the main use case. I'd say that we use this majority of time, and it's about replaying failed request. So just imagine we have register route. You remember this method from our block dedicated to caching runtime data, right? And this time it's about post-tweet endpoint with method post. What we do, we register plugin called, I call this post-tweeter plugin, and we just specify one simple setting called max retention time. So then what will happen? If our user is offline, Workbox will automatically try to replay this failed request when this event will happen. But when? Nobody knows. But it should happen in, I believe, one day in that sense. Control over large downloads. For this block, I found the picture of Phoenix, and you will understand in a second why. Because we want to get to life, we want to respawn when we got some connection problem if we were downloading or uploading a large file. I don't know, for use case could be, for example, web application you build for podcasters. You want, and for listeners of podcasters. You download some episode, okay, and the internet was disconnected, and if, like by default, if you do it, I don't know, for example, via regular caching, you have to start everything from scratch. Or you can say, Maxim, why do we need some extra APIs? We just have a link, download, and the browser will take care of downloading this MP3, and it will work fine. Yes, but will we see the result of download in our JavaScript code? No, it will be just part of file system, and we don't have an access. It's different in mobile native applications, right? So if we download something, we always get an access from the application code itself. It's the same here. So this API called background fetch is about giving us full control on how to download things and what to do after download. Plus, it gives us all tools for us as for developers to track result and even progress. For users, it's super convenient because they don't have to keep the application tab open. They can close this tab, they can switch to some other application, and they can break this download, they can completely put it on pause. Yes, everything is up to them. How it's done programmatically? In main JavaScript thread, you actually specify what to download. In my case, this is some MPGs. You even can provide some human readable name to use this in browser UI. On service worker side, you catch another event. Actually, there is a set of events: background fetch success, background fetch fail, and something else. I remember 3 of them. And you have full control on what's going on after it was downloaded. If it was downloaded successfully, you can put this resource into same cache storage. Of course, take into consideration the quota. And you can show this message to the user using native browser UI. If you want to have more details, there is a blog post I wrote for you. By the way, I forgot to mention that I will tweet the link to these slides right after my session. So this is actually I stream this slide deck from internet, so you will get all the links, all the pieces of code. So no reason to remember these URLs. And UI-wise, it looks like this. So you see, it's absolutely like native browser download, but driven by your JavaScript code, and your JavaScript code has full control on what's going on here. Next point is a bit tricky. It's about scheduled updates of your app and content to keep it always fresh. First, the name of this API called periodic background sync. And let's list first what periodic background sync is not. It's not a cron in the browser. It doesn't has connection independency, and we as developers do not have full control on how often do we do these events. So this is not about this API. It's quite often it's confusing. Again, thanks to this name, many developers perceive this API like something like this. To make cron, there is one more API coming soon to our browsers. It works only online. You might think, is that really useful? Yes, I will explain you why. And the cadence, it's up to browser. So we can only provide minimal interval. So we can say to the browser, please fire these events not often than 1 day in this example. Then browser will decide itself. Will it be 1 day or 2 days, depending on what? Depending on many factors. And user engagement index is one of them. How often, for example, user interacts with this application. Is this a real value to spend battery life and connection bandwidth to do these kind of updates if this application was not open for a month? It's again, contains 2 parts. First, in our main JavaScript bundle, we register this update, or you name it, sync with a minimal interval. And this is like actually only it's the only option we have to provide. Inside our service worker, we catch event called periodic sync, and yes, we can do whatever we want. Maybe. Why do I have maybe here? Because we have to be smart. So technically, it's possible to do pretty much everything inside in completely background, so it will be transparent for the user. But first, consider if the user on cellular or Wi-Fi connection, there is network information API for you. If the user in data saver mode, maybe you don't want to spend extra byte of this poor user, right? Who, for example, I'm on bad connection. I don't want to download anything except, for example, current download I have. And of course, your device is not endless, not your device, but your user device. So we have special API to understand if there's enough place for our user. It might be quite challenging to debug these services. So my advice, enable experiments in your Chrome. Then you will have a special set of background services in your application tab of DevTools. And pretty much every service that intended to run in background is there. Plus, for this periodic thing, you have to explicitly enable this in setting of background tools. Very briefly about what's more coming to the web, and not just coming, but already there in the form of experiment. Native file system API. Super scary API, which is giving access to your file system, to user device file system, straight from your JavaScript code, including writable access, of course. Then, we all love these red circles on our application icons saying how many unread messages we have. Same is going to the web. Access to native lists of contacts also is there. So these three APIs I mentioned are already available for us to test in different form. I intentionally do not give you like the version of Chrome which is there, like origin trial or hidden behind flag, because it's changing while we speak, really. So yesterday there were some updates in terms of where it's supported. And many more is coming very soon. Who can tell me, I'm super happy that I found this picture of flying fish, and it's a special type of fish. Who can tell me the name? Yes, it's a set of APIs called Project Fugu internally in Google. And there are more than, not more, almost 100 of them. And what's really cool, it's publicly available, this tracker. And what's cool is they even have some approximate versions of Chromium when they might appear. We as developers hate to give some dates, right? But folks from Chrome are very brave people. And yeah, why it's called Fugu? No idea. Maybe because of some of APIs are very dangerous, like this fish. So if you cook this incorrectly, you will die. If you, for example, don't take some security considerations in a native file system API, your users will not be happy. To summarize, web today, absolutely ready-to-go place to run what we call applications, and quite sophisticated application, I'd say. It's all production ready. Maybe not all, but at least fundamentals. All this, for example, caching experience, both runtime and application shell, are ready everywhere, even in our iPhones. There is always challenge with this piece of ecosystem, but the basics are there. Really cool tools like Workbox. And let's keep in mind that it's all not for us as developers, it's all for our users. And as you have seen on the previous slide, it's just the beginning. Some useful resources for you. It's PWA Slack. I started maybe a couple of years ago. Now it's like thousands of developers. And Russian-speaking Telegram channel. Always lots of discussions, lots of very pragmatic, practical discussions. And on that, I want to say thank you very much. Спасибо. I will return this slide back.
Thank you.
Welcome here, and we have the first most plus question. It is, are we going to have a Workbox alternative by Microsoft?
There is a very interesting project within Microsoft called PWA Builder. It's about slightly different scope. It's about how to help build scaffolds for your native apps, which include your PWA inside. Some time ago, they had their own service worker as proof of concept, but I heard that they might switch to Workbox again. So no good news from that side for you folks, but let's try community power to build alternative.
Do you think that PWA can replace native apps in future?
That's a very good question. This will never replace native apps completely, of course. Native apps, native code will always have some niche, but for many types of applications. Mainly, I don't know, the ones that does not require like bitwise access to your hardware, does not require 100 FPS. They might replace quite serious, not just apps, but whole categories of apps. For example, if I don't know, if you run some small business, do you really need to hire web team, iOS team, and Android team? Maybe not. And most likely you already have some web experience, so why not to extend it to make as user-friendly as possible on every single platform?
Okay, and what about collecting some metrics? Can we receive somehow what user did when he was offline?
Yes, in Workbox it's just one line, so just like initialize offline analytics. You can imagine that, you can assume that it's done using background sync. So we collect what user does offline, we put everything into IndexedDB, and when we got this event called sync, we just propagate everything to Google Analytics server. So it works like this. And by the way, a friend of mine, Alexey Rodionov from Krasnodar, he wrote plugin for Workbox to do the same with Yandex Metrics. And yeah, by the way, to say more good words about Workbox and to confirm that it's not like developed only by Google. It's open source, and lots of folks from community contribute to core features, to plugins, to Workbox plugins, to their own plugins. So yes, I'm not very fair when I say it's something that we have to struggle with. No, I never say this, and it's something we have to collaborate with, like this.
What do you feel about Lagax?
About what?
Lagax. Lagax.
An instrument written by Sitnik, Lagax.
I'm not sure. What is about? Maybe I didn't recognize by sound.
I suppose that it will be too long.
Can you show me how that's written?
Yeah. Sure.
To be honest, never heard about this. I know many interesting tools from Evil Martians, but not about this one.
Okay. Do you know the way to be offline in Safari Mobile?
Safari Mobile, very good question. Yes, we have service workers in iOS and in iPad OS. They work. They support basic features like putting something into cache, serving something from cache, and so recently we got version 13, right? I didn't install it myself yet, but I know that there are many things fixed and many things added to Service Worker API in particular. Just one example. Before version 13, when we switch between applications, for example, like our PWA is running in Safari and all native apps are running, instead of what's really was in our PWA on the moment when we switched to other app, there was always blank white screen. Like, but now there is a screenshot of what was like the last time before we switched. So it started to feel even more like native. I'd say that there are ups and downs in relation to what's going on about all these APIs on Safari Mobile. But the common trend is going up, I'd say. So folks will get there, but in official messages from Apple, you will never see notice the term PWA. So they are a bit allergic to this. They call this application added to home screen.
Thank you.
You're welcome.
Please choose the best question.
Best question. I think it was about mobile Safari. Yeah, it's always the #1 question.
Okay. Thank you very much. Thank you
You're
again.
welcome.